All right. We're recording in the old school way using QuickTime. So no swearing. All right. I don't know about this whole mess, so let's simplify it. Sorry we missed some of the initial stuff. So let's subtract 2 and then divide by -2. So it's just regular old 6. We could play the two situations games from here. And I think that's probably what you did. And I'm sure you get the same answer. Let me show you a little trick, though. I see 3 in both of those, just to make things simpler. Sometimes this is worthwhile, sometimes not. We could turn this into, let's factor out a 3, and then inside is an x plus 2. We have that property about absolute values, that if you have the multiplication inside the absolute value, you can multiply the absolute value of each piece and they're the same thing. So that's kind of nice because I can take this and call it absolute value of 3 times absolute value of x plus 2 equals 6. Absolute value is just 3. So turns into that. And then you can divide. Right? So then you end up with x plus 2 should just be 2. Sometimes that helps a lot to simplify what you're doing. In this case, probably didn't help that much. It's probably not that appreciable, the change. But let's see what it does from there. So I'm just going to rewrite this up here so I see it. So this is saying the distance that x plus 2 is away from 0, I want that to be 2 units. And if you kind of think about that on the number line, I want whatever x plus 2 is, I want it to be either 2 units up and you get to x plus 2, or 2 units down, right? So that -2 and +2. So 2 units down, I want this to be x plus 2, right? So this situation is that, this is like case number 1, that x plus 2 is 2 units above 0. And the second case, the sad, depressing case, I don't know, is that x plus 2 is down there, which is 2 units below 0. I don't care because I'm just interested in absolute values about distance, right? It's not about negatives and positives. Great. Okay, so there's our 2 cases. And then we can just solve. Subtract 2, that's a 0. Subtract 2, that's a -4. Now my guess is you didn't do this step. Did you get the same answer? Sweet, right? Probably my taking out the 3 was kind of a waste of time. Sometimes it really helps, though. Just so you remember, that's like a trick that you can use. Yeah? Neat. If you weren't sure about it, you could graph it and see if it, like if you graphed this side, or maybe you graphed a simpler version of it. And maybe even this one is easier to graph, because you could say absolute value of x plus 2 is this, but then just shift it over 2 units. 1, 2. And I want to know when that hits +2, and you could find the intercepts that way. You could probably just do it with graph paper if you really needed to. Or you plug these in here, and you see if you get a true statement. Or you check back through the book. Neat? Questions? Is that all right? Right. Bam! Try that one. More negatives. Okay, so my setup, same sort of thing. You can treat this like, I don't know what x plus 1 is, but I want the distance it is from 0. I want that to be, I don't know, we'll call it k. I want it to be k units away from 0, so it's either up at positive k or down at negative k. And I don't really care which, I just want it to be k units away from 0. Instead of calling it k, you could call it this ugly mess, and it is an ugly mess. And so it could be, I'm going to take it at face value, negative 2x minus 5. And then this is negative whatever that is, right? So negative 2x minus 5, and then you can distribute the negative. And so this case is from the top, right, the right side. And I know that there's negatives there, and you're like, but this shouldn't have negatives. It'll all take care of itself, just like let the algebra run. So negative 2x minus 5 is over there. And then this is the opposite of whatever that is, right? It's just on the other side of 0. And so I added 2x to both sides, subtracted 1. I got x is negative 2. Did something similar. I was just careful to distribute those in. Changes the signs. I got x is negative 4. Walk away. You're done. Have lunch.
Check.
Yeah, baby. Thank you. Picking up what I'm putting down. Yeah, right? Like, this is blazing, like, I'm throwing something weird at you, right? Check your answer. Right? What is this, right? They're messing with you. And this is their subtle way of saying that they're messing with you. So, right, they didn't do that here. Oh, they did. I guess they're messing with you here. So if you take this and pop it in here and here, what's going on up there? You'd go negative 4 plus 1, absolute value of that. Does that actually equal negative 2, negative 4, minus 5? That's negative 3, so that's just 3. Positive 8 minus 5. Hey, that works. Ka-ching. I'm happy with this solution. If you play the same game with that, you get negative 2, negative 2, and negative 2 minus 5. Did I put those in right? It's negative 2. Yeah. So you get negative 1, and here you get 4. I missed something. No, you get 1. You get absolute value. And this side gives you 4 minus 5 gives you negative 1. Right? So that's an extraneous solution, a ghost, a phantom. Just like sometimes you get that in quadratics, where a solution presents itself, but isn't actually a solution to the end. It comes out of the structure of your solving method. Cool? They call it extraneous. Extraneous.
How would you graph this again?
You graph it like this. Just if you were going to sketch it. This is x plus 1 and the absolute value of it. So absolute value looks like that. Plus 1 inside the brackets means it's been scooted over, horizontally translated 1 unit. So that's that half. And the other half is just a linear. It's start at negative 5. 1, 2, 3, 4, negative 5. Y-intercept. And then this is the slope. Negative 2 over 1. So down 2 over 1. There's your next point. And that's why it hits only one spot. Interesting, right? Maybe we have is there a graph? Do we have a graph? Don't have a graph, that's okay. You up for one more? Last one. Last one. All right. It's everything you know and love about absolute values, but now you got 2 of them. Think about how to deal with that, mess with that a little bit. there's a lot of different options. And I want to just show you that we can simplify this. So if we chose this and chose to first deal with this absolute value, you could set this inner piece to positive, like this distance is positive and negative, whatever this absolute value 2x plus 3 is. Either it's equal to the positive side or the negative side. Okay, that's confusing, but fine. Now let's treat it like another absolute value, but kind of treat it backwards. Like whatever this is, I want the distance to be this much. Either positive that much or negative that much. And the same thing here. Either positive this much or negative that much. So we've got like 4 cases. It starts getting horrible, right? But if you just look at the signs, we can simplify this a lot. This, everybody's positive. This, if you divide everybody by -1, those are the exact same things. Similarly, this and this are the exact same. Can you see that? That our 4 different possibilities are really just 2 different possibilities? I guess they're like that. You see that? So therefore, when you see this, right, 2 different absolute values, you can cut to the chase and set them equal to each other, break them out of jail, right? 3x minus 4, 2x plus 3. You'll do two sets of those. 3x minus 4, 2x plus 3. And leave one of them both positive, and the other one switch the sign on one of them. Right? We either had the 4 situations were positive, positive, negative, negative, which is the same, or positive, negative, negative, positive, which is this, right? So one is everybody's positive, or everybody has the same sides. The alternative is their signs differ, right? So now you've got your 2 cases, and then you can go. It'll still work if you do the 4 cases. It's just tedious. So x and 7, right? And be careful of that ugly negative. Did you get 1? Yeah. Love it. Check it. Check the round. Bam. 0.2. What happened? Did I miss it? Oh, it's not 1. It's a fifth. It's a fifth. Let's see. Go slower, Berkovich. Add 2. You get 5x. Add, you get 1. You get 1/5. Did you guys see that and just let me blunder through it? You're like, Berkovich, you got fun. Thanks a lot. That's why you check. Cool. Feeling all right about that? All right. Good. Then, try those out. There's a handful of problems right there. These are those double headers. Just make one positive, one negative. No nonsense. Cool. All right. I'll jump around and give you a hand.